So everyone done this question? Exercise question 1, 2, problem 6, 1, 2, 3, 4. Krishna, Fawaz, Ifra,
Yes, sir.
Fawaz, Ifra, have you done your homework?
Yes, sir.
Okay. So start with the question. In the previous lectures, we have practiced on only irreversible process. Today we will do some questions on reversible process. 2 mole of O2 gas expands isothermally and reversibly from 10 liter to 100 liter at 27 degrees centigrade. Calculate the work done. Calculate the work done. Ifra, Krishna, and Fawaz, can you do this question?
Trying.
Okay. Since here it is written that it is reversibly, that means reversible process, and we will use the formula of work done in reversible process. That was, if you are remembered, minus 2.303 nRT log V2 upon V1, right?
Yes,
Krishna,
sir.
Sir, what value of R we have to take? 8.3.
mm, wait a minute, I'm telling you. Yes, you can take 8.314. You have to remember one thing, the value of log 2, which will be used frequently, that log 2 equals to 0.3010. Either it will be given, or if you will remember it, it will be very useful for you in physical chemistry. Log 3 is equal to 0.471, log 5 is equal to 0.69, 69, which can be also written as almost equal to 0.7. Log 7 is equal to 0.845. And then log 10 equals to 1, log 100 equals to 2, and log whenever the 0 will increase, the value will also increase. Any answer?
Sir, minus 11,482.7.
Wait a minute. Any other answer?
Just 1 second, sir. I'm just finding about to find, sir.
Okay, about to find. So, Ifra, what you just said, minus 11,000,
482.7.
82 point, yeah, 88.
Sir, 482.
Okay, okay,
11,482.
okay. So I'm going to solve it. Fawaz, what about you?
So I got 1133.
Okay. So
I'm
here,
doing.
okay, you are still doing isothermally and reversibly. So we are going to apply the formula for work done in reversible process, which is minus 2.303 nRT, right? And then log V2 upon V1. Okay, just see minus 2.303. What is the value of n? That is given
2.
2. That is given in the formula. Sorry, in the question 2. What is the value of r you are going to take? 8.314. So the value will be coming. The value will find out to be in calculated in joule. And what about temperature? 27 degrees centigrade. That means 300 Kelvin. What about V2? V2 is 100 and V1 is 10. So you can cancel this, and it will be something like 2.303 into 2 into 8.314 into 300, and it will be log 10, and log 10 equals to 1. I just wrote it now.
Yes, sir.
So, so you can easily calculate it by multiplying it. Minus 2.303 into 2 into 8.314, and it will be like 11,488.28 joule. Minus, if minus is given, minus just represent that the work is done by the system. Work is done by the system. That means expansion is taking place. Is that clear, Krishna, for us, Ifra?
Yes,
Yes,
sir.
sir.
So negative work done is a scalar or vector quantity. Which physical quantity it is? A scalar and vector.
So we should not take 0.82 as value of R.
That will be in what will be its unit? Just think about it. 0.83. What will be its unit? If you are taking it in 0.03 or 0.83, then the unit will be different, and definitely this value will also be different, but not in joule. Is that clear, Krishna?
Yes, sir.
So, what I asked is work done is a scalar or vector?
Sir, scalar.
Scalar, sir.
A scalar. And if you are saying a scalar quantity, that means it cannot be negative. A scalar quantity can be negative or not.
No, sir.
A scalar quantity cannot be negative, but here work done is in negative. What does it represent? It doesn't represent anything. It just says that the work done is by the system or work done on the system. If negative comes, that means work done by the system, that means expansion takes place. And if work done is positive, that means work done on the system and compression takes place. Is that clear, Fawaz?
Yes, sir.
Okay, moving to the next question. Fawaz, if you have any doubt, ask me.
Okay, okay.
Okay, another question. It's a very good question. 4 mole of helium gas, 4 mole of helium gas compressed compressed wait, 4 mole of helium gas compressed half of original volume isothermally of helium gas compressed and reversibly at 27 degrees centigrade. Calculate work done. Calculate work done. If you have any doubt regarding this, ask me. Whether it is log or whether it is unit. Krishna, can you do this question?
Yes, sir.
Okay. If you have problem in log, then let me know. Okay, let's go. I'm going to make it easier for you. Fawaz, Ifra, just see formula is given half of original volume. If you are going to take, let the volume, initial volume, let the initial volume, let the initial volume be V. Initial volume be V, then final volume, according to the question, final volume will be V upon 2, right?
Yes, sir.
Krishna, according to the question, it is compressed to half of original. That means initial volume is V. That means final volume is V upon 2. Now applying the formula, W is equal to minus 2.303. N is for number of moles, that is 4. R is for 8.314. And T is for 300 Kelvin. And then log, what was the formula? V2 upon V1. That is final volume upon initial volume. Then the final volume is V by 2 and initial volume is V. And you can easily cancel it, and the value will be like minus 2.303 into 4 into 8.314. And here it is 300, and it will be log of 1 by 2. Log of 1 by 2. Can I write it, Krishna?
Yes, sir.
Fawaz,
Yes,
Yes,
sir.
sir.
Yes.
can I write 1 by 2 as 2 raised to the power minus 1? Yes or no? Can I write this, Fawaz, Krishna?
Yes, sir.
Yes. So I'm going to write it like just multiplying this first. What it is? 2.303 then into 4, that will be equals to something like 4 and then multiplied by 300. That will be equal to this multiplication will be equal to, again I'm going to multiply it. Wait a minute. 303 into 4 into 8.314 into 300. That will be almost equals to 22,900. Wait a minute. It will be, so you can see 22,976.5 into, I am going to write it as log 1 by 2 as 2 raised to the power 1. There is a formula in log a raised to the power n will be equals to n log a. What it will be? N log a. This power will come as a coefficient of log. So if it will come as this and the value is in minus here, so you can see minus 22,976.5 and then into minus 1, and here it will be log 2. What is the value of log 2? I just wrote it in the previous slide. Let me know, please. What is the value of log 2? 0.3010. Am I audible?
Yes, sir.
So what I just asked is, what is the value of log 2? You can see 22,976.5 into minus 1. That will be in plus and it will be 0.3010. If we will multiply 22,976.5 into 0.3010, it will come out to be 6,915.9 joule, and it will be positive. That means if it will be positive, that is positive, that means work done on the system. Work done on the system. And whenever there will be work done on the system, that means compression takes place. Is that clear, everyone?
Yes, sir.
Yes, sir.
Please write Krishna and Fawaz, and very good Ifra. You're right now.
Yes.
Okay. So I already have completed questions on a reversible process, right? So today we will start a new topic like internal energy. And then first law of thermodynamics, and we'll go for enthalpy. Very easy it is. Everyone done with this?
Yes, sir.
Yes, sir.
Okay, thank you. Okay, moving to the next topic, which is internal energy. Very important. Internal energy. Internal energy, just see, what is internal energy? Total energy inside a system is internal energy. Total energy. And any kind of energy, it will be like potential energy, kinetic energy, chemical energy, nuclear energy, electrical energy. Just think about our body. There will be, if a nucleus is present, there will be nuclear energy. Chemical, if chemical process is carried out, there will be chemical energy, electrical energy, kinetic energy, potential energy. There will be lots of type of energy in our body, and total sum of that energy will be equal to internal energy. Is that okay? Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So just think about it. Here is a container. Here is a container. And what will be its internal energy? So its internal energy will be, just suppose it is gaseous particles. Here are gaseous particles. Now you know that every gas particles has its own nucleus. There will be nuclear energy. Positive and negative charge, that means there will be electrical energy. Chemical reaction is carried out, that means there will be chemical energy, and a lots of type of other different types of energy that we don't know. So you cannot find absolute internal energy. Can you find absolute internal energy of a system? Just
No, sir.
think about it. We cannot find. But if we know total energy, total internal energy of a system at a time t1, and total energy of a system at time t2, so we can easily find the change in internal energy between t1 and t2, time 1 and t2. Can we find it or not?
Yes,
Yes, sir.
Just think, we can what I want to say is that you cannot individually find all types of energy in the system. But if we know the total energy inside the system, total energy, not type of energy. Are you getting my point, Krishna? Fawaz?
Yes, sir.
Yes, sir.
So here, total energy total energy available in container. What is basically, what is total internal energy? Internal energy is denoted by U. U equals to kinetic energy plus potential energy plus, we can say, chemical energy. We can also say nuclear energy plus electrical energy, and a lot of types of other energy, like dot dot dot, you can say. So I can easily define it here. The total energy, you can write with me, the total energy is stored in a system, in a system or gas, in terms of chemical energy, in terms of chemical energy, kinetic energy, potential energy, electrical energy. I'm just defining it, chemical energy, or any kind of energy, or any kind of energy, or any kind of other forms of energy, other forms of energy is called kinetic, sorry, internal energy. Internal energy. Just write it, it's too easy to understand. The energy inside a body or inside a system, total energy inside a system is called internal energy. If you are done with this, let me know.
Done, sir.
done, sir.
Done, sir.
Done, everyone? Very good. Now see, if I'm asking you that, here is a container in which 10 moles are present. 10 moles of gas are present, and here the internal energy will be U1. And if you are going to take some moles out from this container, and just let's say you just took 3 moles out of this container, then it will be 7 moles and the internal energy U2. And if I'm asking which one is greater, U1 or U2, the internal energy in the first system is equal to the internal energy of the second system, or it will be greater than or equal to. Let me know, please, which container has more internal energy, or are they be equal or more? Krishna, Fawaz, Ifra.
Sir, maybe U1 has more internal energy as it has more number of moles.
What do you say about it, Krishna?
So U2 will have more energy as it has been separated, sir. So it will have some.
Okay, just see. Uh, Actually, U1 will have more internal energy than U2. Why? Because here are number of moles of gases are more. More gas, I can say more gas, and here less gas, I can say. So if number of moles will be greater, that means kinetic energy will be greater or not. That means here 3 moles of gases are less. That means 3 moles of kinetic energy is less. Is that clear?
Yes, sir.
Everyone okay with this? If number of moles are more, that means there will be more interaction between nuclear energy will be greater, and if number of moles are greater, that means kinetic energy of each molecule will be add up to more. Is that clear, Krishna?
Yes, sir.
Fawaz, Ifra?
Yes, sir.
And I already told you that in the extensive and intensive property, that it is extensive property, or an extensive property depend upon size and matter. Remember,
Yes, sir.
it is extensive property. And we already know that in cyclic process it is a state function. Internal energy is a state function. I wrote that in the previous lectures. For cyclic process, for cyclic process delta u equals to 0. I wrote in the previous lecture that for cyclic process delta g, delta u, delta h, delta s, it's all equals to 0 in cyclic process. Do you remember?
Yes, sir.
So please revise all day, every day. What about you, Fawaz? You are so silent. Fawaz is not here. Okay. And next point we can write about it. Internal energy is a state function. It is a state function. And whoever is a state function, their change in cyclic process, their change in cyclic process will be 0. Internally, it is a state function. Next point we can write. I already told you that absolute value you cannot find, so we find change in internal energy. Here I can write the absolute value of internal energy of system can't be determined, can't be determined, only change in only change in internal energy can be determined. So we always find change in internal energy. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, right. Write it. If you are done with this, let me know whenever you are done with this.
Done, sir.
Ifra?
Done, sir.
Okay. Who is this in the background? Okay. Another important point is that how we change internal energy by we can change internal energy by two methods. One is that by working on the system, the internal energy will be changed, or by working by the system, internal energy will be changed. If work done by the system, the energy will be lost and internal energy will be changed. And if we do work on the system, internal energy will be changed. The first one, what I said, how I'm writing it, internal energy of system may change when heat passes. First one is, if you want to give heat to the system, internal energy will be changed. If heat passes by the system to the surrounding, internal energy will be changed. Changed or not, Krishna?
Yes, sir.
If I am saying that if you are going to give the system 10 joule, and then internal energy will be increased. And if you are going to take out 10 joule, internal energy will be decreased. This is the first method to change the internal energy. Another, if you are going to do work on the system, energy internal energy will be changed, decreased or increased. If you are going to do work on the system, internal energy will be changed or not. I'm sorry, internal energy will be increased or decreased, I am asking. Ifra?
Sir, increase.
Increase, sir.
It will be increased. And if you if system will do work on the if system will do work, internal energy will be decreased.
Decrease.
So
Decrease.
by two means we can increase or decrease internal energy. First one is heat passes or given out. Heat passes or given out. That means heat passes to the system or heat given out of the system. This is the first case for change in internal energy. And second is work done on the system or by the system. The internal energy will be changed. So by two methods we can change the internal energy. You can see here. And C, which is very important, matter, that means number of moles, you can say number of moles of gases enters or leaves, or you can say exits the system. You can see that if 100 moles of gases are present in a container, there will be some internal energy. And if you will take 10 moles out of the system, the internal energy will be decreased. And if you will increase the number of moles by 10 moles or 20 moles, the internal energy will be increased. That means it will also depend upon the matter of the gas or the number of moles of the gas. Okay, is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, write it and let me know. Then we will start first law of thermodynamics.
Done, sir.
Done, sir.
Done. Very good. So going to start. Is it clear everything about internal energy?
Yes, sir.
Absolute internal energy cannot be found, cannot be determined. So we determine change in internal energy. Internal energy is a state function. Internal energy is extensive property. Is that clear? In since internal energy is a state function, so delta in cyclic process, change in internal energy will be zero. That is very important. First law of thermodynamics. First law of thermodynamics, also known as float. In short, I will write float. Whenever I will do numerical, I will write float. That means first law of thermodynamics. What does it say? I'm going to write write with me. It is based on. It is based upon conservation of energy. It is based upon conservation of energy. According to Float, first law of thermodynamics, according to Float, the energy of an isolated system, the energy of an isolated system or universe is constant. You already know that. Just the sentence is changed, but the meaning of this sentence is same as we studied in class 9th, that energy can neither be created nor be destroyed. That means it is constant. That means energy can neither be created, energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. It is based upon conservation of energy. This is very important. And according to Flood, energy of an isolated system or universe, the energy of an isolated system or universe is constant. That means energy can neither be created nor be destroyed. And here will be a mathematical formula that change in internal energy delta U equals to Q plus W. Delta U equals to Q plus W. Delta U, you already know that change in internal energy. Delta U, change in internal energy. And what about W? W is work done. W is work done. And what about Q? Q is heat. Here is a reference. Heat absorbed. If heat is absorbed, that means system is heat. Heat is taking by the system. That means heat is taking by the system. Heat is given to the system. You can also say heat is given to the system. That means heat. If heat is absorbed, heat is absorbed. Q will be positive. Q will be positive. And heat is released. If heat is released, heat released by system. That means Q is negative. That means Q is negative. This is very important. That means Q is, why it is so, Q is negative. You can write. I will just derive this formula for you. How it comes delta U is equal to Q plus W. From where the formula comes delta U is equal to Q plus W.
Done, sir.
Krishna?
Yes, sir. Done.
Okay. Just focus here how this formula comes. It's a small derivation to for better understanding. Just suppose here is a system. Here is a system, and the here is the some initial internal energy. U1 is initial internal energy. Initial internal energy of system. U is initial internal energy of system. Then you come, Krishna, and give Q heat to the system. Then you come and give Q heat to the system. Now I'm writing it. If Q amount of heat, if Q amount of heat is given to the system, is given to the system, then internal energy will be U1 plus Q, right?
Yes,
Tell
sir.
me,
Yes, sir.
internal energy equals to U1 plus Q. Then if you come and do some work on this, do some work on this, that means you did some work on the system. So I'm writing work is done on the system, on the system. So final internal energy, let's say U2 will be equal to U1 plus Q plus W, right, Krishna? If you will
Yes,
do
sir.
work on the system, that will add up. Ifra,
Yes, sir, it will.
Ifra, am I audible to you?
Yes, sir.
Okay. Now see, this is this is the wait. This is the final internal energy. This is the initial internal energy. Now I'm going to write U2 minus U1. That will be equals to Q plus W, right? What I just did is final minus initial. That means change in internal energy. This is change in internal energy is equal to Q plus W. This was the formula, or this was the mathematical expression from first law of thermodynamics. So we will use delta U is equal to Q plus W. Everyone okay?
Yes, sir.
Yes, sir.
Okay. Write it from here. It was so to understand in a better way. I just wrote this U2 is equal to, I just derived this formula for you. Done.
Done, sir.
Just 1 second, sir.
Okay, take your time, Krishna.
Done, sir.
Very good. Now here you can see. Do you remember what is path function and what is a
Yes,
state
sir.
function?
Sir.
So state function depends upon initial and final point.
What is path function?
So
Okay,
it
and
depends
what
upon
is
the
path?
path. So it depends upon the
It
path which
depends
is
upon path
taken.
as well. As well,
Yes.
it depends upon initial and final as well as on the path. That is path function. What was the example I have given you? I had given you for path function. Do you remember,
So
Krishna?
heat and work are path function.
Work. I wrote that Q, that is heat, and W, that is work, are path function, right?
Yes,
So
sir.
I'm
Yes.
going to show you something. Krishna,
Yes, sir.
do you remember what is path function?
Yes, sir.
Okay, I'm going to write note, a point note. Q and W are not a state function because it is path function, are not a state function. But you know that Q plus W equals to what? Q plus W equals to delta U. I just wrote it.
Yes, sir.
Delta U is equal to Q plus W, and delta U is a state function, not a path function. But I'm writing here Q plus W is a state function. It's very important to understand and know, because according to Flot, that means first law of thermodynamics, Q plus W is equal to delta U, change in internal energy, which is path independent. Which is path independent? That means a state function. Okay, just write it. Q and W individually are path function, not a state function, but the sum of Q and W is a state function, because Q plus W, sum of Q plus W, sum of Q and W gives delta U, that is internal change in internal energy, which is independent of path. That means a state function. So easy.
Done, sir.
Done, sir.
Done. Very good. Now see, if the process is very easy, it is to understand, just concentrate here. If the process is carried out at constant volume, at constant volume, that means isocoric process, right, Krishna?
Yes, sir.
Constant volume, Ifra.
Yes, sir.
Isocoric process, constant pressure, process, constant temperature, isothermal process. Okay, we know that volume is constant. If volume is constant, that means change in volume, that is dV equals to 0, right?
Yes, sir.
Yes, sir.
And we already know that from first law of thermodynamics, delta U is equal to Q plus W. And if dV equals to 0, then work done, we know that P external into dV, and change in volume is 0, then work done will be 0 or not? Yes or no,
Sir, it will be.
Krishna?
Yes, sir.
If volume is constant, that means change in volume is 0. That means if you are going to find work, and work has a formula minus P external into dV, and this value is 0, that means work done is 0 or not?
Yes, sir. It's 0.
Now that means delta U equals to only equal to Q, right? This is very important. Delta U equals to Q, right? Is there any problem till here?
No, sir.
No, sir.
So the conclusion, what it comes to be, the conclusion, you will write conclusion. Let me finish, then you will write. The conclusion is heat exchange at constant volume. Since the volume is constant, at constant volume, no work done, no work will be done. At constant volume is equal to change in internal energy. It's equal to internal change in internal energy. That means delta U Q or delta U equals to Q only when it will be at constant volume. This is the right symbol for this statement. Q, and if V will be written in the subscript, that means volume is constant. If P will be written in the subscript, that means pressure is constant. And whenever volume will be constant, heat exchanged, that means heat will be coming out, the heat will be given to the system or coming out the system. It will be also always equal to delta U at constant volume. The condition is what? At constant volume. Is that clear, everyone?
Yes,
Both
sir.
of you?
Yes, sir.
Okay. So you were completed. Now you can complete.
Done, sir.
Krishna,
Done, sir.
very good. Now we will come to discuss about enthalpy. What it is, enthalpy. Enthalpy is denoted by H. Before this enthalpy, I'm going to write something. Just see. Before enthalpy, do you know what is endothermic process?
Surf which requires energy to carry out to do reaction, and exothermic which releases energy during reaction.
Okay. Endothermic is a process or a reaction in which heat is required. Is that clear, Krishna?
Yes, sir.
Endothermic is a process in which heat is required. You need to give heat energy to that process to carry out. Is that clear?
Yes, sir.
Yes,
That
sir.
means I can write heat is absorbed. In this type of process, heat is absorbed. If heat is absorbed, if heat is absorbed, tell me about delta U. Will it be negative or positive? If
Sir,
heat is
positive.
absorbed,
Positive.
Krishna, what it
Yes, sir.
will
It's
be?
positive.
It will be positive because heat will be absorbed. That means the internal energy will be increased, and when you are going to find the change, that means final final minus initial, and final is increased because it absorbed some heat. That means for endothermic process, delta U greater than 0. And for exothermic process, going to find about exothermic process. So here is exothermic process. What is exothermic process? Heat is released. Heat is released. And if heat is released, that means internal energy of the system is decreased finally. And when you are going to find the change in internal energy, final will be decreased. That means it will be negative. So here is important thing is that for exothermic process, delta U less than 0.
Done, sir.
Done,
Yes,
everyone.
sir. Done.
Krishna.
Yes, sir. Done.
Okay. So here is what we have: enthalpy. What is enthalpy? Going to define it right with me. It is total heat absorbed in a system at constant pressure. At constant pressure. It is total heat absorbed in a system at constant pressure. The pressure should be constant. We will have a mathematical formula about this. Just see, enthalpy equals to internal energy plus work done PV. U is for internal energy and PV is for work done. Now see, for this formula, it is defined in terms of for this mathematical formula, there is another definition for this mathematical expression. There is another formula. There is another definition in terms of this mathematical formula. You can see it is defined as it is defined as sum of internal energy, sum of internal energy and PV work and PV work at constant pressure. At constant pressure. From this definition, this mathematical formula comes. Is that clear,
Yes, sir.
Yes,
Krishna?
sir.
Now see, you cannot find absolute value of U. You cannot find the absolute value of internal energy. So you cannot also find the absolute value of enthalpy. So here here, just like the internal energy, we determine change in enthalpy. So I'm going to write another line. Write with me. The absolute value of enthalpy cannot be determined. Cannot be determined. Only change in only change in enthalpy. Only change in enthalpy can be determined, can be calculated or determined. Just write it and let me know.
Done, sir.
Done, sir.
Very good. Do you have any doubt till this? I just write the mathematical expression for enthalpy and define in that term. It is defined as sum of internal energy and PV work at constant pressure. This first definition will be cleared after 10 minutes. And is there any doubt in this,
No,
No,
sir.
sir.
Ifra Krishna? Okay. Okay, thank you. Now, moving to the next. We just write that H equals to U plus PV. And you know that we cannot determine absolute value of H. So we are going to take DH equals to DU. And when we differentiate into for quotient, for multiplication, for basically multiplication, we just take first as constant and differentiate another, and then another as constant and differentiate the first one. Is that clear? It is the rule of differentiation you have
Yes,
studied
sir.
in basic
Yes,
mathematics
sir.
in physics. So we just take p as constant and then differentiate v, then it will be dv. And we just took another v as constant v, and we differentiate at p. As we know that, as you know that the pressure is constant. For enthalpy, the pressure is constant. I wrote it for the first
Yes, sir.
definition. Do you remember?
Yes.
So at constant pressure, you can write like this: at constant pressure, dp equals to 0. That means this formula is modified, and it will be equal to, it will be like dh equals to du plus pdv, right? And you can also write delta h equals to delta u plus p delta v. Okay,
Yes,
this
sir.
is for a small change
Yes.
d, and delta is for big change. Okay,
Yes, sir.
okay, write it. Do I need to slide it up?
No, sir.
No need, sir.
Okay, thank you.
Done, sir.
Okay, thank you. Now see, from float, what does float means? First law of thermodynamics. You know that delta U equals to Q plus W, right? And delta H equals to, you know that right now delta H is equal to delta U plus P delta V, right everyone?
Yes, sir.
Yes, sir.
This is the formula from float, and this is formula from enthalpy. Okay, now I can replace delta U from here. I can write q plus w instead of delta u, and it will be p delta v, right? I can write it now.
Yes, sir.
Yes, sir.
Yes, sir. You.
Wait a minute. So here it will be like p delta v. P delta v. What is the formula of w? What is
PV,
the
sir.
formula of w? Please tell me. P. What you just said, Krishna? What is the formula of w?
So PV, sir, before you said that.
Anyone can.
Or we
What
can
you
say
just said?
FT, sir, or force into distance.
Ft? No. What W in terms of thermodynamics? If we are talking studying thermodynamics, W is equal to what? P delta V, na? PdV
Yes, sir.
minus PdV. So delta H equals to, you can write Q and here W equals to minus P delta V from the formula, right?
Yes, sir.
Ifra, are you
Yes,
there?
sir. Yes, sir. Yes, sir.
Okay, P delta V, and here it will be delta H is equal to Q minus P delta V plus P delta V, and you can easily cancel it, and delta H equals to Q. Delta H equals to sorry, and delta H equals to Q. You can write delta H equals to Q when the pressure is constant. One thing is very important. When the volume was constant, heat exchange was equal to delta U. When the volume is constant, heat exchange will be equal to change in internal energy, and when pressure is constant, heat exchange will be equal to change in enthalpy. Is that clear, everyone?
Yes, sir.
Yes, sir.
This is very important. So I reminded it. So I'm going to write another note like I did for internal energy, and you can write it at as conclusion. Heat exchange at heat exchange at constant pressure. Heat exchange at constant pressure is equal to change in enthalpy. सलाद बनाओ. अरे
Done, sir.
very good.
Done, sir.
Krishna,
Yes, sir.
very good. Okay, okay. Moving to the next, we will have a lot of questions. First, we will complete the theory of enthalpy. Then, now see, for chemical reaction. For chemical reaction, we will have another definition. You know that we will have another formula in terms of chemical reaction for numerical basis. Basically, you know that H equals to U plus PV, and you also know that PV equals to nRT, right, Krishna?
Yes, sir.
Infra, for
Yes,
ideal
sir, it
use.
is.
So we can write easily H is equal to U plus nRT. Temperature will be same for a process. R is constant. What will be change? Hey, what will be change only? N, number of moles. Now see, I'm going to derive another formula. Derivation is just for your uh, concept. It is for your good concept. It will be very good to have derivation. Just see here. A is a gas which is converting into B, gaseous state. Now here, if I am applying HA, if I am applying HA is equal to, that will be equal to UA plus NART, right? If I am applying the
Yes, sir.
formula in reactant, then it will be this. And if you are applying formula for the final, then it will be UB
कहाँ
plus
है?
NBRT, right,
Yes, sir.
Yes, sir.
Krishna? Now we know that we cannot find absolute, then we will go for change in internal energy, and change in internal energy will be equal to final minus initial, right? HB minus HA. HB minus H. What is the
Yes,
value
sir.
of HB? That is UB plus NBRT. And what is the value of UA HA? That is equal to UA plus NBRT. and plus NART. Now, what I can write is UB plus NBRT minus UA minus NART. Okay, and you can also write like UP final internal energy minus UA initial internal energy, and then and then here from try to concentrate here from this NBRT and from this NART. I am going to take RT as common. I am going to take RT as common, so it will be wait a minute. So it will be, you can see here it is positive is equal to, I'm going to take RT as common, RT as common. So I took RT as common, and here it will be left NB minus NA, right? Everyone okay with this?
Yes,
Yes,
sir.
sir.
Now see, change, this is change in enthalpy will be equal to final minus initial, that will be equal to change in internal energy, and here it will be product, number of moles of gaseous product. That is very important. If it is given in liquid and solid, just leave it. Okay, take it as 0. Give a number of moles of gaseous product minus number of moles of reactant, gaseous reactant. That will be, I am writing it as delta Ng RT. Now see, here it will be, wait a minute, sorry. So delta Ng equals to number of moles of gaseous product minus number of moles of gaseous reactant, sum of all. And how we find number of moles? We just say the stoichiometric coefficient. Okay, just write it and let me know. Here I'm going to write again.
So can you
Delta
repeat what you
Ng
said before
equals to, wait, I said that number of moles of gaseous product and number of moles of gaseous reactant. How we find? By it, it will be calculated by seeing only the equation reaction. It will be equal to its stoichiometric coefficient. Okay,
yes, sir. Okay.
I will give you examples, very much examples. Krishna,
Yes, sir.
Krishna done.
No, sir. This one's
Okay, take your time. Done.
no, sir.
Done,
Just
sir.
last line, sir.
Okay. Wait a minute. Okay, let me know if anything is not clear.
Done, sir.
What about you, Ifra?
Done, sir.
Okay. I'm going to take 3 examples of 3 types of reaction. Very important. This is. Just see. I'm going to take take example of ammonia. Wait a minute. N2 gaseous state plus 3H2 gaseous state will give 2NH3. Just let me know what is the Krishna, you will tell me first what is the value of delta Ng, and if you are unable to understand, let me know, I will explain it.
Sir, can you explain?
Yes, delta Ng equals to what I wrote is number of moles of gaseous product minus number of moles of reactant, gaseous reactant. Is that clear? Now
Yes.
see, what is the product? Only one, and this is in gaseous state. What is the number of moles of gaseous? This will be find out by its stoichiometric coefficient. What this is 2 mole according to some basics of some basic concepts of chemistry. What is the stoichiometric coefficient of this? N2.
So one.
1.
Answer.
1. 1 mole of this react with 3 mole of H2 to give 2 moles of NH3. That's easy. 2 number of moles of product 2 minus number of moles of reactant. See, first see, both are in gaseous state. What is the number of moles of this? 1. And what is the number of moles of this? 2 minus 4, that will be equal to minus 2, right? That will be equal to minus
Yes, sir.
2, na? Now see, minus 2. Here is a formula delta H. Now you can see delta Ng less than 0. Delta Ng less than 0. And we can also write delta H is equal to delta U plus delta Ng RT. Delta U plus delta Ng RT. And you already found that what you just found is delta delta Ng equals to minus 2. So delta H will be equal to delta U minus 2RT. Can I write it? In
Yes,
place of
sir.
delta
Yes, sir.
Ng, can I write it 2 minus 2?
Yes,
Then
sir.
can you tell me from this equation which one is greater, delta H or delta U? Or will it be equal, or which one is greater? From this equation, I'm giving you 2 or 4 examples. Sorry, options. Delta H equals to delta U. B option. Delta H greater than delta U. C option. And if you are unable to think anything about this, then let me know. And D, insufficient. Insufficient. Insufficient data.
So delta H is less than delta.
Delta H is less than. Are you saying C?
Yes, sir.
Very bad. Just see. Oh, delta H is less than, maybe say you were right. What about you, Ifra?
Sir, don't
Very
know.
good. Don't know. It is C, because the value of delta H is calculated by subtracting something from delta U. Are you getting my point?
Yes, sir.
7
It will be
equals
eight.
to 8 minus 1. That means this is greater than this. Very
Yes,
good,
sir.
Krishna. Ifra, clear?
Yes. Yes, sir.
Then this will be always true. When delta Ng is less than 0, then delta H will be less than delta U. This will be true. Okay. Both of you?
Yes, sir.
Yes, sir.
Okay. Write it.
Done, sir.
Done, sir.
Done. Very good. Just see another case. Uh, you can see second. PCl5 gaseous state will give PCl3 gaseous state plus Cl2. Krishna and Efra, delta Ng equals to, calculate delta Ng.
Sir, 1.
Yes, it is one. Very good. Very good. Krishna, are you
Yes,
all
sir. I
right
got
with
it,
one?
sir.
One.
Yes, sir.
Delta Ng equals to 1. That means, Krishna, delta Ng greater than 0. Can we write? Greater than
Yes,
0. The previous one was less than 0. Efra,
Yes,
can
sir.
I write
Yes,
this?
sir.
Now, we have a formula that is delta H is equal to delta U plus delta Ng RT. Delta Ng RT. And here it is delta H is equal to delta U plus RT, right? If I'm going to put the value of delta Ng as 1, then it will be RT. Now,
Yes.
Ifra, tell me the delta H less than delta U, delta H greater than delta U, equal to
Sir,
delta U,
delta H
or
is greater than delta U.
delta H greater than delta U, because delta H has the value when we add something to delta U. So for this case, delta Ng greater than 0, delta H greater than delta U. Is that clear,
Yes, sir.
Krishna?
Yes, sir.
Case third, we have H2 in gaseous state plus I2 in gaseous state will give 2Hi in gaseous state. Krishna, you are going to tell me what is the value of delta Ng?
0, sir.
0. That's good. Delta Ng 0. Now delta H is equal to, you know that delta U plus delta Ng RT. If you are going to put delta Ng as 0, then delta H is equal to delta U, right?
Yes, sir.
Yes, sir.
So this is the thing.
Done, sir.
Done, Krishna?
Sir, just a second, sir.
Yes. Done, Krishna?
Yes, sir. Done.
Okay. Again, going to discuss about extensive, intensive. You already know that. So here we are. write some points regarding this. Enthalpy is extensive property. Enthalpy is a state function. You already know that I have given examples of all this. Also know that delta H, that means exothermic. Krishna, am I audible?
Yes, sir.
Okay, if you are done with this, then we will study in next class. I'm having throat pain. Will it be okay, Krishna, if
Yes, sir. Yes.
Sir, can you
Krishna,
come again, sir? I didn't get.
I'm having throat pain, I will be coming in next class. Okay, we will have
Okay,
that.
sir.
Do you have any doubt